Hey guys, Mr. Gucci here with your Independent Work Wednesday activity. I'm going to get you started on the 8.2 section of this chapter, which is types of reactions, in which we identify several different types of reactions and then use that information to predict what kind of products a chemical reaction will produce. Now, I'm not going to leap into all of the different reactions that exist. I'm going to start you off with the simplest of the 5 types of chemical reactions that exist. Okay, there's 5 main types, and today we're going to talk about the first and the simplest. And that type of reaction is called a decomposition reaction, where one reactant breaks, let's just say down right there. A decomposition reaction is where one reactant breaks up into 2 or more products, okay, represented by this little equation right here. You have one compound, all right, one reactant that's a compound, say element A and element B bonded together, and then it breaks down into 2 separate elements, A and B, okay? You can always identify that a reaction is a decomposition reaction because there's always one reactant. You always have one compound as a reactant. And if you think about it, if you're given one compound and told to make this thing undergo a chemical reaction, the only thing it really can do is break apart into its component elements. So that's a decomposition reaction, okay? And the products are usually the 2 elements that make up the compound. Sometimes you can have a decomposition with a more complex uh, reaction where it breaks up into smaller compounds. But in most cases, you just have a simple compound made of 2 elements that breaks down into those elements. That is a decomposition reaction, okay? If there's a more complex form of decomposition reaction, I will provide some advice on how to do that, okay? But it's pretty straightforward, okay? So here's how you are going to complete you're going to predict and balance decomposition reactions. Okay, so I'm going to give you a single reactant and I'm going to ask you to tell me what the products are and then balance the equation. Here are the steps. First step, take the single reactant and separate it into its elements on the product side. So if you're given reactant AB, well, then you products are going to be element A and element B. All right, separated. Make sure that if element A or element B are diatomic, you got to make sure that you put a subscript behind them. Remember, these are the diatomic elements. Bromine, if you encounter bromine, well, by itself, it has to be Br2. Iodine would have to become I2. Nitrogen would have to become N2. These 7 elements are the diatomic elements. And if a compound breaks down, if it decomposes and one of those elements is diatomic, it has to form with a doubled up little 2 subscript right there, okay? After you do that, you balance the equation as normal. And again, I just want to reiterate this. Always write down the products first. Write down the separate elements first and maybe give them a little 2 down there if they're diatomic, and then balance. Predict the products first and then balance them when you're done with that, okay? Always 2 distinct separate steps. Let's take it through a few decomposition reactions, and I'm going to get out of presentation mode so I can just show you here. So let's say I give you this aluminum oxide, Al2O3. This substance right here, I know if it undergoes any kind of reaction, it will be a decomposition reaction. And the reason is because I'm given a single compound, and the only thing it can do is break down. So what's it going to break down into? Well, it's got 2 elements here. We've got aluminum as one element, and we've got oxygen as the other element. So right now, I'm just going to write down aluminum is one of the products, and oxygen is the other product. Aluminum is one product, oxygen is the other product. Now, I have to check and see, are either of these 2 elements here diatomic? Let me take a look at my list of diatomic elements. Aluminum is not, but oxygen is. Oxygen is diatomic. So it's not going to produce O, it's going to produce O2. And I'm going to make that into a little subscript, okay? So there we go. All right, we've taken aluminum oxide and broken it down into Al and O2. Now we have to balance. But here, this is just normal territory, okay? We've got 2 aluminums on this side, so I'm going to need to put a 2 in front here. Okay? We've got 3 oxygens on this side and only 2 oxygens over here, so I'll need more. Let me put a 2 right here. Now I've got 4 oxygens on this side, but I only have 3 over here on this side, so I got to increase this with a coefficient. Let me put a 2 right there. Okay? So now I've got 6 oxygens over here, which means I got to turn this into a 3. Okay? But I also have 4 aluminums now. It's Al2, and I've got 2 of them, so I've got to make this into a 4. Okay, and this is the complete balanced equation. The first thing I did was I predicted the products, and then I balanced the equation. Okay, predicted first, and then balanced. Okay, on to the next one, NaCl. All right, well, we've got Na is 1 of the elements. Cl is the other element. So if this thing decomposes, it's going to produce Na as one of the products and Cl as the other product. Now, what I need to do is I need to check and see, are either of these diatomic elements? Na, sodium, or Cl, chlorine. Let me take a look. Na is not one of the diatomics, but Cl is, chlorine is. So this breaks down, it's not going to form Na and Cl, it's going to form NaCl2. Okay? Those are the 2 products that are produced. Again, the decomposition reaction is simple. Okay? You're just given a compound with some elements in it, and they basically almost always, unless I say otherwise, are just going to separate into those elements. And now we have to balance it. Okay, we've got 1 Na on this side and we've got 1 Na on that side. Okay, we've got 1 Cl on the reactant side and 2 chlorines on the product side. So we got to put a 2 in front here. Okay, putting a 2 in front. But then that changes our sodiums. Now we've got 2 sodiums over here and only 1 over here. So I'm going to put a 2 right there. And now we have a balanced chemical equation. Okay, so there we go. There's another example of a balanced chemical equation. Let's try the third one. Okay, lithium phosphide. Okay, we've got 2 elements here. Lithium is present and phosphorus is present, which means when this breaks down, it's going to form just straight up lithium and just straight up phosphide. Now, are either of these 2 diatomic? Let me go check. Lithium, lithium, lithium. Lithium is not diatomic, and neither is phosphide. Neither of these are diatomic, so the elements that are produced are just Li for lithium and P for phosphorus. That's it. There's no subscript needed. They're not diatomic. Now we can balance, okay? We've got 3 lithiums on this side and only 1 lithium on this side, so I'm going to put a 3 in front. Okay, we've got 1 phosphorus on this side and 1 phosphorus on this side. So that's it. They're balanced. This is the balanced chemical reaction. Very good. Okay, now these are your most common decomposition reactions. Again, you have a compound with 2 elements, and all it does is just break down into those elements that make it up. Keep in mind here that you're just writing down the symbols of the elements. You know, Al2O3 breaks down to Al and O. And then you just got to double check to see if any of the products are also diatomic. In this case, O is diatomic, Cl is diatomic. Okay. Now, you will occasionally encounter decomposition reactions that are a bit more tricky. Na2CO3, sodium carbonate. Now you're thinking, what could this break down into? Could it be only 2 things? I see 3 elements. I see sodium, I see carbon, I see oxygen. Okay, that is absolutely correct. I would not expect you to be able to figure out what 2 products are produced here just by giving you this thing right here. Like maybe you're like, whoa, do I make Na? Do I make Na and CO3? You wouldn't, that wouldn't be far off to guess that. But in this case, no, you're not correct. This is not what you produce. In fact, what you produce is one of your products is Na2O, so sodium oxide. And the other thing you produce is CO2, carbon dioxide. So you see, in fact, the Na, the sodium takes an oxygen, the carbon takes two oxygens, and they break up into two compounds. This is technically a decomposition reaction. All right. It's just a little bit more complicated. And so I would not hand you a problem like this without giving you enough clues to solve it. And on your homework, you will have a few questions that are like this, that are decomposition reactions that are a bit trickier, but I believe I give you the clues you need to solve it. Okay. So your independent work activity today is to do this worksheet. It's real simple. All right. It's real simple. You got like two two free response questions, and then you've got like a few of these fill in the blank type questions. Okay, nothing too hard, I don't think. Okay, one more thing I want you all to work on, and I'll make sure it's uploaded to every classroom. I've also uploaded the latest and hopefully last of my fill in the blank calendars. All right. So if you haven't done so, I've made this 5 points in the test category. All right. So you just want to make sure you do it sometime this week, even early next week. Fill in your schedule. If you filled in one of these before, you can just paste your schedule in. And I also recommend you include room numbers and include what cohort you are in. Are you cohort A? All right, who comes in Monday, Tuesday? Are you cohort B that comes in Thursday, Friday? Are you cohort C? That's all virtual. All right, as soon as you fill this stuff in, it'll auto populate your calendar until the end of the year. Okay, really useful. Even if you're not coming in right now to hybrid, there's a good chance you will before the end of the year. Here's my schedule. I not only put my classes, I put my room numbers as well. So, for example, I know that on the Thursday, February 11th, when we get back, I will have period one chemistry in room C260. Then I have a break. Then I have period three chemistry also in C260. Pretty light day for me. Feels good. All right. And I won't get confused about what classes I have or the rooms that I have them in. And that's important because I think almost every single one of my classes, we have like one day in the cycle where we're not in our normal room. And so you want to have this schedule made up so that you know that and you're ready for that. Okay, so those are your two assignments for today. All right, do the chemical reaction worksheet, decomposition, and then fill in your autofill calendar, which should give you your class schedule, including vacations and stuff, all the way to the end of the year. All right, guys, I hope you have a good day. And please send me a message if you have any questions. I will be online to help from 2 to 2:30. All right, later, guys.